Hi friends, here in this video I'll be explaining the problem on epicyclic gear train. So let's get started. Now here is the question in front of us. It is given an epicyclic gear train of sun and planet type has a fixed outer wheel A. So the meaning of it is here we have a sun wheel or sun gear at the center. Then there is an outer wheel or the bigger wheel, also called as the annular wheel. This is an internal gear. Then sun wheel is rotates at a speed of 600 rpm. The speed of the sun wheel is given, and the rotation direction, if not specified, we can take it as clockwise direction, that is the sun is rotating in a clockwise manner. Next, and the spider C carries 3 planet wheels. Here this element which is there at the center, this is the spider. So here we have spider denoted by C, and it is carrying 3 planet wheels as shown here. These are the planet wheels having number of teeth as 27 and the sun wheel has number of teeth as 18. Then which are to be driven, it means the planet wheels would be driven by the sun gear. We have to find the required number of teeth on the annular wheel, that is how much teeth are there on this outer gear or the internal gear, we can say. Next, and the speed of the planets, or at the same time we have to find out how much is the speed of these planet gears. So when we have understood the question, let us get started with the solution part. Into the solution part, first I would be explaining how to get the number of teeth on the annular wheel. For that, I would be using the geometry of the given figure. So from the geometry, I can say that starting from this center up to this end, here we have the radius of the annular wheel or the bigger wheel. Now that radius is made up of the radius of this sun wheel plus the diameter of the planet wheel. I'll explain it in this way. Like here we have from the center up to the sun wheel, this will be the radius of the sun wheel, and then this is the diameter of the planet wheel denoted by d suffix p, and the radius of the sun wheel is denoted as r suffix s. So I can simply say that the radius of the annular wheel, radius of annular denoted by r suffix a, that is made up of the radius of sun wheel plus the diameter of planet wheel. So therefore the radius of the annular wheel is equal to radius of sun wheel plus the diameter of the planet wheel. Next, therefore, radius of annular can be written as the diameter of annular wheel divided by 2, that is half of the diameter. Radius of sun wheel similarly can be written as the diameter of sun wheel divided by 2, and this diameter of planet wheel will remain as it is. Then also the relation is between the module, that since module m is equal to the pitch circle diameter, which is capital D, upon the number of teeth, and here whatever diameters we are using, these are the pitch circle diameters. So from this I can say that diameter is equal to module into number of teeth. So replacing the diameter with module and number of teeth, so therefore instead of d suffix a, I can write down module into number of teeth for wheel A. Similarly for the sun wheel and for the planet wheel. Then for two gears which are in mesh, the module should remain same, then only they will be in mesh. So module is constant, for both the gears it is same. So module would be cancelled out from all sides, and whatever is left, I'll write it over here. That is the equation which remains. Since module it is same for both, so I'll write it is constant. Same for both, we can say both sides of the equal to sign, that is for the planet wheel, sun wheel and the annular wheel, the module is same. Now from this equation, the number of teeth on the sun wheel is given, it is 18. On the planet wheel it is 27. So the answer of number of teeth on annular comes out to be 72. That's the first answer, that is I've calculated the number of teeth on the annular. Now the second part of the question, where we have to find the speed of the planet gear, and for that I would be using the tabular method. So the heading is calculation. Calculation for speed of planet gears, and for that the tabular method, and here I'll draw the table. Now the columns are, first would be the number of steps, second column operation, means here I'll provide the description of the operations performed. Then the next column would be for the arm, because we are going to keep the arm as fixed. So remember, when you have such problems, keep the arm as fixed, and that is the arm, or we can say the spider. So here spider is denoted by C. So I'll write down that it is spider or arm C. After that, the sun wheel is driving the planet gears. So motion would be given to the sun wheel and then to the planet wheels. Next we have sun gear. Then we have planet gear. At last, the annular wheel. So I'm going to write their revolutions over here. Now, in the first step, step number 1, operation is keep the arm fixed. So arm or the spider C fixed. Keep the arm C as fixed and give +1 revolution to sun gear S. So I'll be keeping the arm as fixed. So it is 0, the speed of the arm. For the sun gear, we are providing +1 revolution. Now I need to find the speed of the planet gear. So for that, I'll explain how to get it. We have to use the velocity ratio concept. We have to find the speed of the planet gear. Now planet, it is driven with the help of the sun gear. So the sun gear is the driving gear, whereas the planet gear is the driven, and sun, I am assuming it to be rotating it in a clockwise sense. So these planet gears would be rotating in an anti-clockwise manner. So since the direction of rotation between the sun and the planet, because they are external gears, is opposite, so the velocity ratio would be given by, since velocity ratio for sun and planet, it is speed of driven gear, and driven gear is planet, upon the speed of the driving gear, which is the sun gear, is equal to negative sign. Remember why I am putting negative sign? Because they are external gears, the direction of rotation is opposite. That is why we have to introduce a negative sign. And then in front of the number of teeth of for the planet gears would be, or we can say in front of the speed of the planet gears, there will be the number of teeth for the sun gears, and similarly at opposite to the speed of the sun gear would be the number of teeth on the planet wheels, because the speed and the number of teeth, they are inversely proportional, and therefore now we have given +1 revolution to the sun gear, so therefore the speed of the planet would be minus, this will be 1 into ts by tp, hence np is minus ts by tp. So this is the speed for the planet wheel. I'll write it into the column. Then annular wheel. The same concept would be used to find the velocity ratio for the annular. Now, annular wheel is driven with the help of the planet gear. Planet gear is rotating in an anti-clockwise sense. Since the annular wheel is an internal gear, so the connection between the planet wheel and the internal gear is such that when the planet wheel rotates in an anti-clockwise manner, it will also rotate the annular in an anti-clockwise sense. So since the direction of rotation of speed of the planet wheel and the annular wheel is same, then the velocity ratio would be positive, and it would be written as, since the planet is the driver and annular is the driven, so speed of driven, which is annular, upon speed of driver, which is planet, is equal to inverse proportion for the number of teeth. So here we have number of teeth on planet upon number of teeth on annular wheel. And why it is positive? Because of the nature of rotation, that is, since for internal gears the direction of rotation is same, so that is why I have taken it as positive. And between the sun and the planet, since the direction of rotation is reverse or it is opposite, that is why we have to take a negative sign. So remember this point. Now therefore NA would be NP into TP upon TA. Now NP is in front of us, it is minus TS upon TP into TP upon TA. So TP and TP gets cancelled, and what remains here is the speed of the annular is equal to minus TS upon TA. So into the next column, the speed of the annular is minus TS upon TA. Then the next step, in this I would be multiplying by small m, which indicates RPM throughout. So small m into 0 for the arm, it is 0, plus 1 into m, that is plus m. Here we have minus m into ts upon tp, then minus m into ts by ta. Next, adding small m, the next step is add small n to all the elements. This small n also indicates the RPM, whose value we are going to find out. So here it becomes small n because n plus 0 is n. Here we have m plus n, then minus m ts by tp plus n, and minus m ts by ta plus n. At last I'll write the total motion. So the last step is total motion. For arm C it is small n, for sun gear it is m plus n, for the planet gear and for the annular wheel. So this small n indicates the speed of the arm, denoted by n suffix c. For sun gear, m plus n, n suffix s. For planet wheel or the planet gear, n suffix p. And for the annular gear, n suffix a. Now these are the speeds which I am going to use while calculating. So starting with the first condition, it is said into this problem at first only that an epicyclic gear train of sun and planet type has a fixed outer wheel A. So I'll be using this condition, that is first keeping the outer wheel as fixed. Since the annular or the outer wheel is fixed, it is given. So therefore, speed of annular n suffix a is equal to 0. And therefore, from the table, the value of speed of a is minus m into ts by ta plus n. I'll write this is equal to 0. Number of teeth on the sun wheel given in the problem as 18. For the annular, we have calculated number of teeth. It came out to be 72 plus n is equal to 0. So therefore, here we have minus, this will be 1 by 4. So it is minus m by 4 plus n is equal to 0. Keeping this as the first equation. Then another part which is given in the question is the sun wheel S rotates at a speed of 600 rpm. It means keeping the annular fixed, the sun wheel is rotated at 600 rpm. Since the sense is not given, I am assuming it to be a clockwise sense, that is positive speed. So therefore, in a similar manner, since the speed of the sun wheel is given as 600 rpm clockwise, and if we are assuming it to be anti-clockwise, then it becomes negative. So I am assuming it to be in a clockwise manner. So therefore, the speed of the sun gear can be taken from the table. It is m plus n is equal to 600. That becomes equation 2. So therefore, solving equations 1 and 2 simultaneously, because we have two equations and two unknown, that is m and n. So solving them simultaneously will give me the answer as m value comes out to be 480 rpm and n value comes out to be 120 rpm. So after getting m and n values, I can directly go into the table and find the speed of the planet, because that is what we have to find out. So therefore, speed of the planet gears denoted by n suffix p, and it's equal to putting the respective values. M came out to be 480, so minus 480. Number of teeth on the sun wheel, it's 18. On the planet, 27 plus small n, which is 120. So on calculating this, I'll get the value of the speed for the planet as, it comes out to be minus 200 rpm, or I can say that it is 200 rpm in an anti-clockwise manner, because here the assumption was clockwise speed is considered as positive and anti-clockwise as negative. So this much is the speed for the given planet gears, that is 200 rpm in an anti-clockwise direction when the sun wheel is rotating at 600 rpm in the clockwise direction. So in short, that was a problem regarding the epicyclic gear train. At the end, if you all find my videos helpful, you all can like, share, comment and subscribe our channel and share it amongst your family and friends. Thanks for watching.